Hey, everybody. So, to welcome everybody. So today we are on week 4 of our Sisyphus challenge. We're on to phenotype evaluation. So last week you heard from Christian and Gautam, who went through the process of showing you how to create concept sets for exposures in the case of Christian, and then Gautam walked through using Atlas to create cohorts for aortic aneurysm. And so this week, what we're going to hear from is JPEG's going to walk through the steps of how to execute cohort diagnostics and illustrate the specific example of how you'd run cohort diagnostics and iterate through the process of evaluating your aortic aneurysm phenotype. And then Evan's going to walk through the process of clinically reviewing the results of aortic aneurysm across an instance of cohort diagnostics that's been run across 5 databases that have now been publicly posted. For purposes of the live demo, we'll have Evan go through and work it through himself, but then we'll post the link into the chat so you guys can all play with it yourself. The high-level goal for today is to make sure that everybody in the call is familiar with how to run cohort diagnostics yourself to evaluate a phenotype on your own, which we consider to be an iterative process. So we want you to be able to be familiar with how you do that. That's particularly relevant on this call as it relates to new data sources that are going to join our fluoroquinolone study. We're going to be able to do some assessment that Evan will walk you through on a couple databases, which include some like US claims data sources. But one of the things we've learned from our community is that evaluating a phenotype is really something that you need to do across each of the data sources that's going to participate in a given study. So just because a phenotype works in one database doesn't mean that you can necessarily expect that it will perform similarly in another database, which is why JPEG is going to walk you through how to do phenotype evaluation locally. When Evan goes through the process, you'll kind of understand the clinical perspective. And for those who want to share cohort diagnostics results, we can post them up on the Odyssey website, where Evan's going to be showing you, you'll be able to play with that yourself. My hope at the end of this is that based on Evan's recommendation, that we can at least be clear about whether or not we're moving forward with the definition that we've created based on the review, or if Evan convinces you all that there's substantial problems with it, then we can know exactly what we need to do an iteration. But I think that hopefully this will at least build confidence collectively in everybody's understanding of the phenotype that's been constructed. I'll also just highlight one thing that's asynchronous. Joel Swerdell posted a tutorial on how to run phEvaluator as an approach to quantify measurement error in a phenotype. He actually posted a tutorial that I think Craig either has posted or will shortly post it on the Sisyphus Challenge webpage. And he walks through the steps to run phEvaluator specifically for the end-stage renal disease outcome that happened to be used in the VEGF study that was covered earlier, but the steps to follow it are identical, and one could follow that process to evaluate aortic aneurysm. So that's another phenotype evaluation trick up our sleeves that encourage you guys to consider as it relates to this study. But with that, I'll turn it over to JPEG to start with the how to run cohort diagnostics in your own environment, and then we'll go through with Evan the what did we learn on this definition. I expect we'll have some time for discussion to reach a consensus by the end of this hour.
Thanks, Patrick. Hi, everyone. As I assume most of you don't know me, I'm Jamie, also known as JPEG. I work in Patrick's team at J&J and do a lot of the software development for our Hades R packages, but specifically I'm the lead developer on cohort diagnostics. So this talk's going to be about giving you ability to familiarize yourself with cohort diagnostics, show that there's not too much to run to get yourself off the ground, kind of explain what we mean by iterative phenotype evaluation, provide some resources to me or other people in the community that you can go to when you need help, and then kind of get you to the point where you can actually like go through your own data in a local instance. In a future tutorial, we'll go through the actual like study process for running this with our strategist package. One of my colleagues will do that, or I might be jumping in to help out with that too for this session. But at this stage, we don't expect you to need to share any data with us. That will be kind of handled then when we do the full execution of everything involved with a study. So kind of give you a bit of background on cohort diagnostics. In my opinion, the most crucial part of any study is actually developing good phenotypes, because obviously if you have an effect estimate that you've generated or some kind of prediction you made from your research, if your outcome phenotype is junk, then that prediction is going to be junk. So this makes it super important to critically evaluate whether your phenotype is reliable or not. And unfortunately, in a lot of the observational literature, you'll find very few standards, if any, outside of Odyssey that exist to kind of critically evaluate those phenotypes in a reusable manner. So obviously, this is going to lead to investigator bias. You will pick a cohort that matches your narrative of your study, which we obviously do not want to do. We want to be as general and applicable as possible in our phenotype algorithms. And in order to do this, we developed cohort diagnostics, which is an R package which you can run on any OMOP CDM compliant data. And just like phenotype algorithms are never finished, they will always iterate. Cohort diagnostics is never finished. We're always adapting it to new problems. So, the first thing to do when you want to run cohort diagnostics is to set up your R environment. I won't go through that in detail here. I think Mark touched on it in the first kickoff session for this. But if you go to our R Hades guide, you will find a very, very extensive guide on getting your environment set up. There are a few crucial environment details that differ from most R setups, in that you'll need to have Java installed, and you will need to have a GitHub personal access token. And that's important because after a certain amount of downloads, you won't be able to download any more packages or update any more packages from GitHub for however long it is before they refresh your limit. So you need to create an account and then get this access token. But that guide sits there, and I leave that for you to complete outside of this. As I said before, we don't expect you to share any results from this process. This is, as much as anything, it's familiarizing yourself with what you would expect to share from running a study. Having said that, almost every code block in this tutorial can be copy and pasted into your R session or into a text file. This study, I can paste it in the chat later, but this full slide deck will be hosted online for you to review at your own pace. So, the first step after having your R environment set up is to install the required packages. And we do that with another package called Remotes, which allows us to install from GitHub. So we can install from our GitHub repositories. And in this tutorial, you'll need to install Cohort Generator, Cohort Diagnostics, our Odyssey Web API, which is how you will connect to Atlas and to quickly and easily download cohort definitions. And you can do this in a reproducible, repetitive manner. So you can change the cohort definition, and then when you change it, we will run something called incremental mode, which allows cohort diagnostics to know that the cohort has changed and only run the analysis steps necessary for that new changed cohort, not for anything else. So if you repeat this study, you'll get different results based on that cohort. And then lastly, Odyssey Shiny modules, which is our package for our Shiny apps, which is separate from everything else. But all our Shiny apps go into that. Well, not all of them. All of the Shiny apps relevant to this study will go into that package. to allow you to install. There is another way to install from an rnvloc file. I won't go into that here, but it's an alternative kind of approach to make sure it's reproducible in the sense that the packages you install will be the same as everyone else's, but you don't need to worry about that for now. So once you've got your environment set up for installing, you will need to get the cohorts. And we've hosted these cohorts on the demo atlas, as Gautam was showing last week. And there you just need to go to the cohort definition view and click on the IDs and copy the IDs. It's not super easy to copy the ID. Unfortunately, it kind of loads up the cohort directly. But if you find the correct cohorts and then copy the IDs, that's like what you will need to basically run this study. I have done that for you here, some of the cohorts that Evan will go through later, but these are the ones that are relevant to this study that you can run. Crucially, you'll need to enter the base URL for the Atlas demo odyssey.org website with this trailing web API following it. This will be different for any internal atlases that you have, and they also might have some kind of form of authorization. There's various different ways that you can log into Atlas via our Odyssey web API, so it's a bit too much to go into here. But for this demo, you shouldn't need to log in. You can just literally copy and paste all of this code here. You get the correct IDs that we found on the Atlas website, and then we use our Odyssey web API package to export them into a R data frame that contains all of the necessary things that you need to run these cohorts. Similarly, if you want to save these cohorts so you can run them in a firewalled environment, say, I know a lot of sites have that, or a few sites have that condition that their CDM can't be connected to any external external IP connections. That you can do too, but again, I won't go into that because it's a bit of a side topic. But that is possible too. Following that, you'll probably want to view these cohorts, so just view them in your R session. You can use the R view function if you're not familiar with it. In our studio, that will bring up a table, and you should get a full table listing them, making sure that they're correct. It's pretty important to do that because otherwise you could waste hours running analysis on the wrong cohorts. So just a tip to always check that. It's a pretty common mistake. Next, you want to get your CDM connection settings set up. This bit is the one part of the talk that I can't make copy and pasteable. So you'll need to figure out this based on your own CDM requirements, what database platform you have, the server that you connect to, the port or any other connection details that go into this object, and then your username and password. One thing that we really strongly recommend, because it's been a problem in the past with people sharing their username and password for their data. We don't, their databases. We don't want you to do that. So we strongly advise you use the keyring package. It's pretty simple to get set up, and it means you can set your keys in your R session for reuse, and you won't have to risk sharing any of them with us. Following your connection details, you want to set your database ID, which is any string, but probably you want it relevant to your specific data set. Then your CDM schema for your database, and then your cohort database schema where your results live. So this schema needs to be writable. This schema only needs to be readable. Then we'll just set a folder for the results here. We'll just call it results, and it will be in your current R working directory, wherever that lives. Probably when you create a new project, that will be the same folder. And similarly, we're creating an incremental folder, which is very useful for phenotype evaluation because we don't consider it, something you do once. You'll likely have to change the cohort definition, add new cohort definitions, remove them, adjust as you add clinical insight from that process. The next step is to call the cohort generator package. This is a standard package across all of our study utilities in our R packages to let you generate the cohorts in a consistent way, so we know that the tables are correctly generated, and you can use the same parameters in other packages like cohort diagnostics to get the cohorts. And this makes use of the incremental mode 2 in its own way. So if you generate a cohort once, it won't be generated again unless that cohort has changed in some way. And internally, we track those changes. You can turn that off if you encounter problems, but I wouldn't recommend it because it's probably one of the longest steps in a lot of studies. Following cohort generation, you'll want to call cohort diagnostics to actually generate your analytics step. And this is relatively straightforward, if you've got the previous steps set up. You just need to pass in the parameters that we set before in terms of your cohort definition set, your connection details, your database schemas, the cohort tables that you use, the data folder that you actually want to export to. Here we set that to the results folder and then the database ID, because in some cases people use multiple databases. That may not be the case in most people's experience, but it's a good idea to kind of separate them out anyway, especially if you have different versions of your CDM, if you do multiple ETL cutovers multiple times a year, say. Then we set incremental mode to true, and again in the same incremental folder we passed into cohort generator. And then crucially, the most important parameter, I think, from your own understanding of your data that will be limited according to your personal data compliance rules, is the min cell count. And so this is actually the minimum number of patients that can be aggregated before you share results. So if this the result for any covariate in this is less than 5, we're saying here, then you will not see the number of patients that covariate relates to. So you will only get that as a qualitative value, I guess you could say, that somebody has had that covariate in your data set. You won't know the exact number, you'll just know that it's between 1 and 5. And that's important in terms of identifiability, because if somebody has in principle one patient, say, or a small number of patients have a given covariate, it's easier to identify them. So it's super important to set this correctly according to your own requirements that will be either legal or license based for your data. And then following that, you can configure which settings you would like to run in cohort diagnostics. Evan will go through all of the results following this, but you can turn on or off these depending on your experience with how long they take or what you actually want to do. I know quite a lot of people will only run a few checks on a given cohort, and that can be good if you're happy that your cohort is specific enough. You may only want to adjust it based on some kind of sensitivity parameter that you're changing in your definition. And then following executing, which will take probably a few hours. I can't say how long it will take, but it will be based on your your hardware, your setup for your data set, or the size of the data set particularly will affect it. But following that, then we want to merge the results, and this is a step that just creates an SQL-like database that you can use to actually explore the results in a Shiny app, or you can query it with just standard SQL queries. But this approach lets you merge that into a file, and then following that, you can launch a Shiny app locally that you can view, and then following that, you could share that with other users. But I leave that to another study. Sorry, I leave that to another follow-up talk, because we're not intending to do that here. Yeah, if you have any questions, you obviously you can follow the guides we have, but please reach out in the Odyssey Teams or the Odyssey forum. You can also email me. And then if you have any issues, please post them on our issue tracker. I try to get back to them within a day or two. It's not always easy to kind of manage that. So apologies if I don't get back to you right away. If you do have something super urgent, please just email me directly. And yeah, I hope you have a good experience using the software, and please give me any feedback you have from this process. And following that, I think Evan is going to take over and take you through actually exploring the Shiny app.
Thanks, JPEG. Any questions for JPEG before we transition over to look into the results? All right. If not, Evan, all you.
Great, thanks. And thanks for the opportunity to be involved and to talk to you guys this evening. My name is Evan Minty. I'm a general internist. Usually, I'm on sabbatical this year. I work clinically in a hospital in Calgary, Canada. I did my master's through in biomedical informatics through Stanford, and I for many Odyssey purposes, I stay onboarded there with Nigam Shah's group, and I've also been doing some work this year with Patrick and his group, largely in the area of phenotype development and evaluation. So I took a slightly different tack than was taken this morning with Aza's presentation. I really actually recommend it. That's recorded. It's a great walkthrough of cohort diagnostics. I was trying to combine a little bit of overview with also trying to get to some of the questions that we're facing with this study with respect to phenotype. So I don't necessarily go through a walkthrough in the same way, but I do look to try to give a high level overview as to what we're doing in the phenotype development and evaluation process. And I'm hoping that ties together with some of the things we do dig into with respect to the phenotypes. And I do take a look at some of the indication phenotypes, in part because I actually think it's a nice introductory step. In this case, the outcome phenotypes, in particular looking at a composite, I actually found to be quite complex in terms of how to attack it. And I've taken some steps. You'll notice on data.odyssey.org that there's actually a lot of phenotypes there. I'm sorry that that's not really a simple thing to navigate, but certainly the urinary tract infection ones will be a good place to start if this is your first time walking through cohort diagnostics. And part of what's posted there is actually what's reflected by that iterative process that everybody keeps referring to in terms of teasing apart the phenotypes that you're looking to evaluate. So we'll look to give that overview. We'll talk about database level validation with cohort diagnostics. Again, the easiest base case being given by the urinary tract infection phenotype, and then the aortic aneurysm and dissection. I think there's a role for discussing how some supporting cohort definitions can contribute to your analysis of a cohort diagnostics experiment. And we'll touch on the role of the probabilistic reference standard with Phevaluator, although we don't have any Phevaluator results at this point. In terms of that overview, I borrowed the kind of conceptualization here from a thread that really should be in the Odyssey Forum thread Hall of Fame. So this is kind of some representations that I'd seen that Martin Schumi had put up and that I learned a lot from. But what we're looking to do within that evaluation process, what I've represented here is that purple cloud is patients with a recognized disease or condition that have some distribution of features that reflect the severity, acuity, patient context. And what we do within medicine or when we're doing research is look to delineate the disease entity with some diagnostic criteria and eventually draw some kind of boundary here shown with that dashed line. And our clinical description phase of the phenotype design process looks to ensure that investigators share that mental model of that line. We then look to construct a phenotype definition. In this case, we're looking at rule-based models as an approximation to that mental model. And then what's often done outside of Odyssey is traditional validation, which usually looks at an in-sample sample for case review, kind of shown here with V1. Sometimes you'll see out of sample review shown here with V2. But obviously that it relates to just patients in one database and isn't something that really scales easily across a network of databases, which is really where Odyssey's strength lies. And so what cohort diagnostics allows us to do is trade up to looking at phenotype definitions across that network of databases. And what you'll invariably find is database heterogeneity is the rule rather than the exception, and should certainly calls into question our previous assumptions in using chart validation studies as something that validates a cohort for use more broadly than a single database. So in terms of our objectives within a particular evaluation, we're looking to review that population level data that we see through cohort diagnostics against our expectations, largely aligning to domains of diagnosis, therapy, and prognosis. Odyssey, we try to boil things down into rules of three, I've noticed. So I'd say those are the main areas of clinical action that that will produce the data exhaust that we see in cohort diagnostics. Within each of those domains, we look for sources of measurement error, with the main three being sensitivity error, so are we missing the right people? Specificity error, do we have too many of the wrong people? And index date misclassification, something that suggests that the condition of interest is actually starting before or after the index date as you've defined it. And so starting with urinary tract infection and the exposure phenotypes, I find it helpful to summarize those main domains of diagnosis, therapy, and prognosis in a table like this. I did this quickly. It's not an authoritative source at all. These domains, like I said, diagnosis splits into things that largely affect your construction of a prior, so the incidence rate, demographics and visit characteristics, risk factors, signs and symptoms, and actually with some of this I drew on and replicated some of Anna's columns in Keeper, trying to make sure that we kind of stayed aligned in terms of I think there's a lot of different work that's kind of putting the hands on the same elephant, so to speak. And so I think a lot of these categories align into, again, the way you would categorize the data exhaust that you're going to look at. And it's helpful to make sure you've refreshed and got, in some ways, a condensed form of what it is you're going to look for in terms of attributes in the cohort diagnostics result and how they align to that real-world mental model. With respect to urinary tract infection, this actually, again, forms a good baseline cohort diagnostics experiment where we've got one cohort in UTI here, and we're looking to align the results we see to that mental model, again, shown in the dashed line. And some things that I noticed, so this was just looking at cohort counts. It's one of the very first tabs that you'll see in cohort diagnostics. So very large cohorts. This top row is all urinary tract infections. I looked here initially at a couple of different databases that returned first, so Australia and the German Disease Analyzer. In looking at the incidence rate, I thought it was interesting. The table that I just had in the slide before and other references you might consult suggest there's about a 4-to-1 prevalence of UTI in women versus men, and our incidence rates largely reflect that. But the second thing that I thought was interesting in this cohort, when it comes to the kind of extension of our indication phenotype to an exposure phenotype, is the considerable drop-off in trimethoprim sulfamethoxazole, so Septra or Bactrim or TMP-SMX, as I've written here. In one database in particular, at least at the time I looked at this, which was Australia. So a considerable reduction in terms of exposures relative to other antibiotic classes, although the fluoroquinolones there were also fairly low. We'll revisit that trimethoprim exposure in a second here. In walking through the different realms of diagnosis, therapy, and prognosis, in UTI, one of the things I looked for was whether or not we could find evidence that a urinalysis was completed. That's often one of the only diagnostic tests that you would need to diagnose UTI, especially in an outpatient. It may or may not even be done, and it may not be well captured because it's typically a bedside test. Well, it's typically a laboratory test, but you certainly can do it at bedside with different kits, and so it may not be something that is well captured in data exhaust. And just to highlight, what I mentioned about database heterogeneity, in looking at for urinalysis, I could find that evidence of that within Optin and MarketScan, for example. So about 26 to 22% that seem to get some kind of measurement or some kind of representation of urinalysis in the measurement domain, but none in by that covariate in Australia or Germany. But I could find evidence in another way that they were getting the same test done, although at a lower prevalence. So looking at, for example, urine sediment, I could find some results that suggested that there was a urinalysis done. It's just not quite captured in the same way. That's of some relevance to some recommendations later around what we might do for next steps in the UTI phenotype if we think they're required. With respect to therapy, I think I'd mentioned earlier, this is the same table that I showed initially, that there was a pretty considerable drop-off in TMP-SMX, although in retrospect, looking at this, I think this is actually something that I believe Jack had mentioned that we might anticipate in terms of the use of cephalosporins versus fluoroquinolones in Australia. But one of the things I noticed when looking at other entries in the drug domain is that we did actually have a lot of trimethoprim. I'm not familiar with the patterns of practice or drug distribution in Australia, and I don't know if trimethoprim is used without the sulfamethoxazole component, but there actually was a fair bit more trimethoprim used than just trimethoprim sulfamethoxazole. So that might actually affect how we would conceive of our indication, our exposure phenotype that we might want to consider iterating to make sure we're not missing a substantial portion of people that are just exposed to the TMP component or trimethoprim component as a comparator to fluoroquinolones. And just to be complete in looking through some elements of prognosis, these were largely outpatient databases that I was looking at the time. But one thing I did find was that in the 31 to 365 days that followed, within those two databases, there were at least another condition occurrence for urinary tract infectious disease. And interestingly, in looking around for estimates of urinary tract recurrence, I found an estimate that 20 to 30% have a recurrence within 3 to 4 months. So that lines up well. And I couldn't really get a sense in looking at it, I think largely because it's an outpatient, those are outpatient databases, as to complications or progression of UTI to cause sepsis or pyelonephritis, or other downstream issues with infection, which might be addressed in referral centers or in hospital. I could find a referral to hospital entry in the German database, but I don't think it's particularly informative, and I couldn't really find any stats in terms of progression of UTI to requiring hospitalized care. I did look at a couple of other variants for potential exposures and disease indications, in part because one of the things about UTI is that it can be such a short course of antibiotics. Oftentimes 3 days is sufficient for treatment, and in looking for an effect of fluoroquinolones, that might be a fairly short course. And I just thought I'd throw this out there, that one thing I did look into was prostatitis. And this gentleman pictured top right, I'll give you guys a multiple choice. His expression is either A, the concerned look of an epidemiologist who's just been told he has prostatitis, or B, the concerned look of an epidemiologist when he is confronted with evidence that Australians are largely immune to prostatitis, or C, the concerned and inquisitive look of an epidemiologist who suggests that we pursue evidence of a biological gradient in exposure. And what I think is interesting here is that it looks like that this would be, at least in these databases, well, at least in Germany, be feasible, and I think it's feasible across other databases. This would do a couple of things. One is we would recover some gender balance in terms of our studying of this topic, because prostates are largely confined to the male anatomy. The other thing, though, is that prostatitis is a pretty stubborn infection, and we typically measure time for treatment in weeks rather than days. And so as opposed to a 3-day course of antibiotics, we'd be looking at 4 to 6 weeks sometimes. Fluoroquinolones are used widely, and so is Septra, because they both penetrate the prostate pretty well. So might be an interesting component to consider in this study of a pre-specified or subsequent subgroup that focuses on prostatitis, to see if we can find that dose-response relationship that Bradford Hill, who's the gentleman actually pictured, suggests is one of those criteria for causality. So then a quick summary then, I would suggest that with the indication phenotypes that we could consider using cohort diagnostics results to create a adjunct for urinalysis that might allow us to kind of create a more specific cohort that allows us to kind of characterize it otherwise with Phevaluator, and provide some ground truth within cohort diagnostics as to what a UTI might look like otherwise in the data. That there might be an exposure sensitivity error with the discrepancy that we saw in TMP SMX versus trimethoprim exposure, and that we consider prostatitis as a pre-specified subgroup. Jumping now to what was a bit more of a complex area, which is the outcome phenotype. So aortic aneurysm and aortic dissection. And in particular, what was complex about this is that we were looking to consider a composite. And I'd never really looked at a composite phenotype in cohort diagnostics before. I have to admit, I kind of went down a road of looking to try to find ways to decompose this, in part because if you take a look at, if you consider aortic aneurysm as a condition for which we generally survey with regular ultrasounds in people who have appropriate risk factors versus aortic dissection, those two conditions are quite different, and they're each generally addressed separately in terms of clinical ideas. And so I anticipated kind of struggling to interpret things like incidence rates of a combined phenotype, where I don't really have a reference where I can find an incidence rate of a combination of that composite in a textbook anywhere. And so that's made further complicated by the fact that actually within our vocabulary, aortic aneurysm rupture is rolled up under aortic aneurysm. And that's obviously a very different entity than something that we typically survey for. In many ways might be more similar to aortic dissection than aortic than just a standalone aortic aneurysm. In as much as they're both emergent conditions, high mortality, may require very similar interventions in terms of endovascular grafting or surgery. And so what I'd suggest here is that we try to decompose these into their constituent component diseases, not because I don't think we should do a composite outcome, but just in terms of the phenotype evaluation and validation process, that was a way that I thought we might be able to validate validate those constructs and then combine them again into a composite, but with the knowledge that, or having made the case that independently they look like valid phenotypes. But this proved to be a bit of a challenge, and I'll show you why. This is just a figure that I modified from BioPortal, and it shows the descendants of aortic aneurysm here. One of the descendants of aortic aneurysm is ruptured aortic aneurysm. And so that's great. You would think that would allow you to roll out or roll up or exclude all the different ruptures that might otherwise be in the tree. But the challenge that exists is that within each anatomical area, so aneurysm of the thoracic aorta, a descendant there is also thoracic aortic aneurysm, which has ruptured. And that actually was the case when I looked at other places in an anatomical tree. The challenge within the Odyssey phenotype construction process is that if even if I list ruptured aortic aneurysm as an exclusion, the fact that it has a lineage where I have other inclusions, which I would want, and that it can be rolled up into that other parent, that concept will be grabbed through that parent then. So in other words, inclusions kind of trump exclusions. And so at a concept set level, this is going to be very hard to disambiguate. The other thing that was going to make it challenging is that, and I think it's, I think it provides a parsimonious definition, the fact that we have, a combined concept set that includes procedure occurrence, but having procedure occurrences, and this is probably quite hard to read, but one of them there is repair of well, in this case, thoracic aortic aneurysm with insertion of an endovascular stent graft. That could conceivably be entertained for an expanding aortic aneurysm, but also entertained for an aortic dissection. That these procedures might not be, I don't think, are cleanly going to be, are not going to allow the clean separation of aortic aneurysms versus dissections versus ruptures. And so I think we get to 3 initial population level questions with respect to our outcomes. The first one is, we could potentially disambiguate this if we don't think there's actually much additional value being realized with that procedure domain component to our definition. And so we'll take a look at that. The second question is, can we examine aortic aneurysm rupture, and aortic dissection separately? That might help, again, with the population level validation in both cohort diagnostics, but also with Evaluator. It does not preempt us using a composite, as I mentioned, but it also might allow us to consider different downstream composites that might be of interest. So, for instance, the effect of fluoroquinolones on the progression of aortic aneurysm to either aortic aneurysm rupture or aortic dissection. And then finally, one of the questions that came up is, what was the impact of requiring primary position diagnosis codes, which was the 2 variants that Gautam had shown you guys being constructed, one with a condition occurrence in any position, or just in the condition occurrence table, excuse me, and one with the additional attributes that it's in the primary position of a admission record or discharge record. So the first one was pretty easy, looking at the impact of removing procedures. Excuse me. This is just looking at the condition counts. And the main message here is that there's, in moving from the first row to the third row, we're removing contributions from the procedure criteria. And I'm looking here at Optum-EHR and CCAE. And so the drop there is very, very small. The independent contribution of procedure codes. So in other words, the cases where we have a procedure code where an aortic aneurysm or dissection or rupture is being addressed with a procedure and we don't have any diagnostic code information is very small. And so I would suggest that in terms of our ability to disambiguate, we could probably remove that procedure occurrence criteria without much of a increase in our measurement error. The second one that was striking was the very large drop in moving from any position to the primary position for either aortic aneurysm or aortic dissection. And we'll take a look at the significance of that, but obviously there's a very big cost to requiring the primary position. Not shown here is the cost that might be incurred in looking at non-US or other international databases where that primary position is less well used or signifies something different. In moving from primary position to any position, I just thought it's worth kind of taking a high-level look as to what we're doing. There's many different ways we can look to try to expand a cohort definition or refine it to minimize sensitivity, sensitivity error, or specificity error. The one that we're looking at doing here is largely kind of shown by this first arrow, moving to expand from an initial kind of primary position cohort to one where it's any position. And so conceptually, what we're looking at doing here is comparing these 2 cohorts, and that can be a challenge because of that superset relationship. And so one of the things that I think is helpful here is to introduce another helper cohort or helper cohort, like I mentioned earlier, in this case, XSpec. So this is just a what I would anticipate to be a highly specific definition. It just adds more stringent criteria. It obviously has a use in training reference probabilistic standards with evaluators. So the idea there is that in part with XSpec, you would train a representation of that disease cloud to, shown here in that red line. But I also find them to be useful in a cohort diagnostics experiment because they provide kind of a sample that's within the middle of presumably, or might be biased, but it's at least close to the middle of the distribution of people that definitively have the cohort, or definitely have the condition, sorry. And then I can do some cohort comparison experiments against something where I feel like we have something that I feel like we have some ground truth to it, or at least our best estimate that we can get to. So here's what I found in my attempts to separate aortic dissection versus aortic aneurysm and aortic aneurysm rupture. I cover the first two here, but the results from that third one are similar. And in particular, looking at aortic dissection in the primary position versus what I just constructed some very basic XSpec cohorts, which just required 3 occurrences. So 3 conditioned occurrences in a hospitalized record of aortic dissection. And what we thought was interesting is that you see some elements here that are off diagonal. So I'm just looking here at the plots, and I think they kind of provide a high level overview. So the plots that can be generated with the cohort comparison tab. In those plots, there were more aortic dissection concepts in the target here, which was actually in the primary position. And actually, this is actually something that held true throughout the rest of the analyses that I looked at. I think that what was the message that was being delivered here was that having aortic dissection once in the primary position was a more specific definition than having it 3 times in the hospital record. And so my anticipation of what was the more specific cohort was actually wrong. It's probably actually the primary position. And we might actually even kind of invert this situation to consider that it is suggesting, a trade-off where we might look at repeat condition occurrences as a way of expanding, but not in the primary position, as a way of expanding our cohort definition slowly and evaluating that difference relative to having it in the primary position. I hope that makes sense, but if we're looking to expand beyond those numbers that we see with the diagnoses in the primary position, but think that just having it once is too non-specific a definition, then it looks like just requiring repeat condition occurrences might be the way that that find a middle ground. I'm just noticing the time here. I want to make sure we leave some time for questions and discussion. But the other thing I noticed is that looking at aortic aneurysm as a primary hospital, as a diagnosis in the primary position, looks like it probably is quite similar to has features at least of both aortic aneurysm, but also dissection or rupture. And I think that largely relates to the fact that if you are getting an aortic aneurysm code in your in a primary position in your record, there might be some miscoding of either acute aortic syndrome events where it just kind of is labeled very broadly as an aortic aneurysm, or you might just also be getting interventions that are in keeping with that are similar to those that you'd get for aortic aneurysm and for dissection and rupture. I did have a little bit more to go through with respect to looking at the role of things like a marginal cohort. So in particular, one of the things that is helpful is, especially when we're looking at a situation like this where we're expanding from, in this case, our initial or our middle or our smaller circle there, which was having a diagnosis in the primary position, to having that diagnosis in any position. It can be a challenge, like I mentioned, to evaluate those two and compared to each other, just because you don't know how many of those features are being driven by the cohort that's being superseded by the larger one. And just to kind of give you a high level overview, if I compare this this larger set of having any position for aortic aneurysm or aortic dissection to just having it in a primary position. I might be convinced that these largely look like similar cohorts. I could take a look at the tables and probably see a numerical representation of what we're seeing here in these covariate plots, where we are seeing largely on diagonal elements. But if I then take the example of what that marginal new contribution is, so having diagnosis in any position but not in the primary position, and compare it to the ones in the primary position, I see quite a different figure. And so I think they can provide a clarifying role in terms of new contributions that are being added to with the changes that you've made in the cohort definition. And overall, in these cases, I couldn't convince myself that having a single, and again, this is very kind of rapid overview, but I couldn't convince myself that having a single occurrence was going to be sufficiently similar to what we kind of were establishing as ground truth in cases where we had high confidence that those were that those conditions had actually occurred. I'll skip over the next slide just to provide some initial recommendations and that really kind of riff off of the questions that I had before. So what additional value is being realized with procedure domain component? It appears to be very, very small, and we could probably safely discard it. Can we examine aortic aneurysm rupture, and aortic dissection separately? Possibly. There's evidence in the inpatient environment that codes might be getting used interchangeably, but it also raises the question, oops, I'm sorry, as to whether we could consider an aortic aneurysm phenotype as an outpatient, because that I do think is probably a bit of a different entity, something that's being kind of diagnosed with routine surveillance than it is when it's coded, especially in a primary position in an inpatient stay. And so in general, what's the impact of requiring primary positioning of the diagnosis codes? So considerable in terms of cohort sizes. I had some concern with specificity errors when using just a single occurrence. And I suggest we quantify those with the evaluator. If we could consider requiring additional conditioned occurrences, because those cohorts actually look like they will have more people in them than just restricting it to having the primary position, with the added benefit that we could use more databases, especially non-US databases. And this might be an area where we just do some quick profile review to kind of confirm our suspicions with respect to that ordering of relative ordering of specificity. So I think that largely kind of provides also the summary recommendations. I don't think that this slide adds much more. I'd much rather kind of take any questions and hear comments from the rest of you guys. So thank you very much, and big credit to a lot of the work that went on to develop this study, and to the work that went into developing these cohorts through Patrick, Gautam, JPEG, and others.
Thank you, Evan. I see that Edith has his hand up, and also there's a couple questions in the chat here. So if you want to raise your hand to ask questions, and I'll chime in too.
Sure. And what I might do is end the show here. Well, I don't know if I'm going to need to share my screen. Do you mind just calling out the questions? I just don't have a great view of the audience right now while I'm sharing.
Sure. Yeah, we'll just go through. Edith, do you want to go first, and then Nicole?
Yeah, sure. Thanks, Evan. That was amazing. There's so much to think about there. So it sounds like it's boiled down to a decision around diagnosis and what position and which ones, right? And to me, it seems like you were suggesting, and correct me if I'm wrong, that there might be a hierarchical kind of inclusion criteria where we might say anybody with a diagnosis in the primary position, we're pretty sure that they have the problem. Then we might say an or we include people that have multiple diagnoses, not in the primary position, but somewhere else along the way. So it's kind of like a building up of ors here, rather than, I think what you were doing in the first cohort was just any diagnosis anywhere, not requiring there to be something in the first position. I may not be explained probably, but I think what you're suggesting is we build up, but in the end, we may not have the ability to separate out the different indications, right? Or the different, types of outcomes.
Yeah, I mean, I agree, and that's actually a very common design pattern that we wind up falling into, right? Where we have something where we're quite certain that that the diagnosis is present, then we might conceive of combinations of criteria. An alternative would be to look at something that generalizes across different databases that just, if we are uncomfortable, and I kind of got the sense that I was anyway, if just a single occurrence of this diagnosis, of requiring, 2 or 3, and then see if that's something that, remains a parsimonious definition that we can accept across the entire network. That might be an alternative way of tackling this. I do want to pursue, in part because the results are there and I didn't get to dig into them as much as I would like. Each of these as separate entities to get a sense as, can I prove out some comfort that we are finding each of these things separately, and then, but that's not to kind of weigh against doing a composite outcome. It's just simply to kind of provide some empirical evidence that I think we're identifying aortic aneurysm events, aortic dissection events, and aortic aneurysm rupture events, and then we can combine them with a bit more confidence in terms of referencing existing literature or other things to help corroborate the fact that we're seeing what we expect within these particular disease entities.
So Evan, I think I missed it, but just to follow up on Nicole's question, before we were to think about going off and making new definitions, we want evidence to support the assertion that the current definitions are not sufficient. So I think I may have missed it, but what evidence did you have to suggest that the one code at any position is bad?
Yeah, I mean, so I guess, and I guess I kind of extended it, that we'd have to treat each of those. I hope, would you guys be in agreement that we would treat each of them separately in terms of the kind of constituent components? Because I'm not advocating against using a composite. It's just that I don't know where to reference things like incidence rates if we're kind of considering a composite, with respect to, comparing our population level results against a mental model of disease. And I would definitely concede that there's, not much in this presentation to say that, we definitively can't use a single occurrence. It was in looking at kind of the prevalence of the off-diagonal elements when comparing it to things that we thought represented that ground truth. My general kind of gestalt has been, we might see kind of expansions in that in the features that kind of run along the diagonal. But when we start to see things that look quite off diagonal, then it starts to, it generates some concern that we're dealing with a different cohort of people. But I wouldn't say that I've proved that out sufficiently, in the course of this call. And so would gladly kind of take that on as a challenge to see, if we would all accept or would all be, comfortable or not comfortable using just single occurrence of the codes.
So let me just parrot it back to make sure I'm hearing it correctly, Evan, and I apologize over a couple minutes over. Part of the issue is maybe the primary position one is just a different composition of these 3 different ideas: a non-ruptured aneurysm, a ruptured aneurysm, and a dissection. And in particular, the primaries, or lots of them, are the dissections because they're the serious bad things that cause, and as well as the ruptures. Whereas the non-ruptured aneurysms, if we had confidence that they were non-ruptured, are the less serious and less cause for hospitalization. If we were to break them up and you were to show that primary versus any were on the diagonal for each of the 3 components, then you would probably be reassured that using the any was a perfectly fine strategy. Yeah. But because you see slight difference, and we don't know, is the difference because of the composition of the components or because there's some fundamental clinical difference of the cases, that's what's giving you pause currently.
Yes. Yeah,
Got it.
and I think a lot of that has to, there's more work that I have to do digging into the actual, table versions of these cohort comparisons. Just didn't have time for necessarily, but that's the general gestalt I was getting when I was mousing over a lot of those covariates, finding kind of things that look like these were different admissions, or there was different kind of prevalence of different things. That's just they were there for different reasons, and maybe this was just an incidentally coded thing because it exists on a problem list. That's the impact I'd like to investigate a little bit more.
Got it. I know we're a few minutes past, but any other questions for Evan or JPEG?
I haven't got a question, but Evan, what can we do as a group to help you with that? I mean, you said you would like to, look into the tables and investigate further, but what instructions or what homework can you give all of us to help you with that?
That's a really good question. Why don't I take that away? I mean, one thing we could do is we could look to have another call with the benefit of a little bit more time to dig into this as a group. I mean, the results will be up on data.odyssey.org. Again, I apologize in advance because there's a lot of cohorts there that reflect some of the iterative processes that were involved in thinking through what we might need to prove out that we can separate these things out, and then to look at them separately. So it's a bit to tackle kind of as an initial as an initial cohort diagnostic challenge, but it's certainly one that we could take on collaboratively. And to be honest, would definitely want to be bouncing off the findings with a broader group, and calls like this provide a great forum for that.
Great. So perhaps we can set up a separate meeting for interested people. Yeah, great.
Sounds great.
Sounds good.
I think I saw. I'm not sure about the ordering of the hands. I did see Adam's hand go up. I'm okay to sit and chat. I find it invigorating and helpful, so no problem.
It was more a comment than anything. I think as we kind of, it was really interesting when you pointed out the spec part, the fact that if there's multiple conditions, it more than likely. I think as we kind of look at this as a global study, we would have to think through the time window to capture those multiple diagnoses as with care practices, just to make sure that we are actually accounting for care practice variations that allow people to either be seen more or less across countries. So it'll be interesting to kind of create a model on justifying if repeat diagnoses codes within a certain amount of time are scalable enough to be compared across countries.
Yeah, that's a really good point. In this case, we're looking at repeat within the same admission, but the point still stands that starts to impose requirements on the density of a particular record of care. And one of the insights that has come from doing profile reviews across different databases, that you can get markedly different, even within the same database, you can get markedly different densities of a care record. And I don't know enough about the provenance of some of these databases to understand what within the data collection process, harmonization process, et cetera, leads to that.
Yeah.
But one of the reasons I'm was careful to kind of say that XSpec as a ground truth label might well be biased. So if I require 3 conditioned occurrences, that imposes some requirements on the density of that care record to meet that condition. So it's not sitting in the center of that disease cloud. It's off, but I am pretty sure it's in that dotted line. And so in that sense, I find it a helpful helper cohort to have in a cohort diagnostic experiment, because I can be comparing to things where I feel like I am pretty confident about the ground truth. Any other questions at all? Thanks very much.
Thank you,
sorry,
Evan. I appreciate you. I appreciate you going through this and so thoroughly. And I do think we need to follow up. I also think it'd be great for us to be able to run P-Evaluator on these outcomes, because I find, and I see this in literature often, we sometimes get enamored by positive predictive value and don't think about the adverse consequences of the sensitivity fail we'd have here. So when we see that we lose whatever it is, in this case, like we have an 8-to-1 ratio of lost cases when we go from primary to any, on the one side, one could say, oh, geez, that must be a lot of extra noisy cases. But the other way of thinking about it is, crap, we might be losing 80% of our cases if we restrict to primary. And so I think it's actually really important for us to estimate sensitivity and specificity and positive predictive value to understand if either or maybe both of these definitions would be sufficient to move forward with.
I 100% agree with you. And actually, the slide I skipped over looked to make that point. And one of the things that I know that is on a lot of people's minds is, especially if I'm able to define some, there's nothing about expect that's hard to define up front usually, right? Like usually that's something, like I said, I actually find it helpful to have within a cohort diagnostics experiment. But I think we could be quite explicit about, if we generate that phi-evaluator, those phi-evaluator results in advance, there's, I think, the opportunity to be quite a bit more quantitative here about what exactly is being added as a marginal contribution as I, in this case, expand that cohort definition exactly as you said, based on that estimate. And even kind of the things that I'm doing, looking at, off-diagonal elements. I mean, these are all things I think would be, quite amenable to similarity metrics that aren't even, and I think that probably would add some value as well. Just looking at some cosine similarity or something else that that means maybe over time we can start to develop some cutoffs that very similar to what we have in our other design processes that suggest we should probably stop here if we're getting a cosine similarity that's less than this, or stop here if we're getting that trade-off in cases added to removed from the evaluator. But totally agree, and it'd be really useful to include those further upstream in the development process.
Very good. Well, thank you, Evan. Thank you, JPEG. Appreciate your time today. And we'll follow up in the MS Teams chat for the study as the next step.
Thanks, guys, and sorry if it wasn't totally clear at the first pass.